Welcome everyone. My name is Andrew Davidoff. I am engineer with Microsoft Office team, and today I'm going to make a presentation about Exchange Server protocols. Exchange Server protocols are part of larger open specifications. So I'm going to do an introduction of Microsoft Open specifications, just a refresh very briefly. Then I'll talk about scope of Exchange protocols, go into details of several protocol families, give some recommendation of what protocol family to use for different kind of solutions, and provide some resources that will be helpful if you are using protocols for your solution. Introduction to open specifications. This documentation is quite special. It is using normative language, and it is designed to document bits over the wire. There are no APIs, only protocols. We use endnotes to document version-specific behavior, and for that we follow RFC 2119. The document structure is very strict, and it helps to maintain consistency across large set of documents. There are hundreds of them. Important to note that Windows or Exchange or product API knowledge is not required. It's bits over the wire. Microsoft products are not even mentioned in normative content, only on endnotes. And speaking of scope, we document only protocols used by on-premises Exchange server. Some highlights on open specifications. In client-server communication, there are two endpoints, client and server, and most open specifications and Exchange protocols as well, they document server endpoint. So normative content prescribe behavior of server endpoint. However, for Exchange documents specifically, we have quite large number of documents that also document client endpoint. And the reason for that is that Outlook behavior is quite complex, and it needs to be documented in normative way to a large extent. So we have client behavior section and server behavior section in a large number of documents. Another highlight is product versions. We don't specify product versions in normative content. We prescribe just how protocol behaves. But if there are variations depending on specific implementations, this is stated in appendix, in special appendix, usually appendix A, product behavior. And normative content refer to that using endnotes. Here's an example that I have. That's from one of the documents. You can see the normative statement here, and it has some content mentioning endnote 6. If you look at endnote 6 in this document, it says that Exchange Server 2003 and 2007 do not support certain property. This is how we do this version-specific documentation references, and that's the only way you will see product versions in protocol documentation. Let's take a better look into Exchange protocol scope. This picture shows interesting divide. We have Exchange Online as part of Microsoft 365 services. and we have Exchange on-prem. If you use Exchange Online, it is recommended that you use REST APIs or Graph APIs. If you use Exchange on-prem, then documents in open specifications are your big help, and that's protocols that you want to use for your solutions. Okay, let's talk about Exchange protocol details. Glossary. RPC is remote procedure call, network term. ROPS, remote operations, this is Exchange term. MAPI, mail API used by Outlook and supported by protocol family RPC ROPS. MAPI HTTP is transport layer, where HTTP is used instead of RPC to transfer remote operations. EWS is Exchange Web Services protocol family, and EAS is Exchange Active Sync protocol family. This picture shows a role of protocols in client communication with Exchange server. You see, we have different devices, different platforms, and those devices have can have client implementations using different protocols. For example, smartphone in this here is using EAS. Outlook for Mac, this is using EWS, Exchange Web Services. Outlook for Windows Desktop is using MAPI, but it's also using EWS for certain features. We can also have POP or IMAP client that use standards implementation on Exchange server. And the important point here is that no matter what protocol is being used, they all work with the same data. It's just that access to this data is being done using different ways, different protocols. And they all have very special purpose. So it's important to understand that depending on your solution, you need to choose what protocol to use. And there is more to Exchange than just email. We have calendars, tasks, contacts, reminders, notifications. We also have rules, out of office, mail tips, compliance, archiving, and so on. And all those features are being represented by specific protocols. Good starting point is overview document, MSOX Proto. It defines protocol families. It shows how protocols work together, and it has very good walkthroughs and examples. So definitely a place to start if you use Exchange server protocols. And the picture on the right is from MSOX Proto. There are several protocol families defined there, ROP protocols. Originally it's RPC transport. And I will talk about this in more details. We have Exchange Active Sync. We have Exchange Web Services. And we have other protocols, name service provider, MAPI properties, and so on. ROP protocols family. There is a long history of terminology for this protocol family. The initial name is RPC protocols. In fact, it is remote operations, ROPS, over RPC connection. That's how it was designed initially. And RPC is just a channel to exchange binary blobs between client and server. This binary blob can be transmitted by other underlying protocols, use like RPC over TCP or RPC over HTTPS. And we also use pure HTTPS to transmit ROPs, and this is MAP HTTP. It is RPC replacement and first introduced by Exchange Server 2013. And since it's not RPC anymore, we now call those protocols ROP protocols. In many places you will still see Exchange RPC protocols, and sometimes it calls MAPI. Details. Transport layers for ROP protocols is RPC over TCP, RPC over HTTPS, or pure HTTPS. It provides low-level access to Exchange server. It's significantly optimized to minimize traffic on the wire and has very complex parsing. It's used by MAPI, and it's major channel for Outlook and Exchange communication. Outlook for Windows Desktop and Exchange server communication. Originally implemented in Exchange 4.0, which was first release of Exchange, and extended re-architectured multiple times. ROP protocols define both server and client behavior. Client behaviors are very complex. They are wrapped in MAPI implementation on Outlook for Windows Desktop, and client performs logic to maintain complex items like messages, folder, calendar, tasks, contacts. All of them are maintained by client. There are over 40 protocols and 3,000 pages approximately of documentation. So here's an example of complexity, why I mentioned that it's very complex. You can see that binary blob, which is transmitted over transport, has ROP size, which is pointer to the server object table at the end, and then ROP after ROP after ROP after ROP, and ROP has ROP ID and ROP data. There is no end marker. And that makes it quite difficult to parse. The solution, the application that using this protocol family needs to be able to parse all ROPs possible, and there are more than 130 of them. This large set of documentation is highly hierarchical, and this picture shows you where to start. Start with RPC or MAP HTTP and MSOX ROPs, and then this set of server-specific protocols and client-specific protocols. And finally, to summarize, this the protocol family is not recommended for new applications, and there are very good alternatives on modern Exchange server, Exchange Web Services for on-prem, and Microsoft Graph for Exchange Online. Exchange Web Services. Web Services is alternative to ROP protocols, provide much higher level of abstraction compared with ROP protocols, and AWS implements messages, attachments, calendar events, contacts on server side. Outlook for Windows Desktop uses subset of AWS protocols for unified messages, mail tips, availability, Office apps, rooms, archive, policies, and so on. It is intuitive and readable XML, so troubleshooting is easier. And transport here is SOAP or HTTPS. Documentation in protocols. You can code in any language that supports HTTP SOAP calls. SDKs are available as well. Documentation is this protocol set is 43 protocols with approximately 2,000 pages. First implemented in Exchange Server 2007, and important that new on-prem features tend to be implemented in AWS. Where to start? Those protocols are not hierarchical, so start with MS or XVS core and then look into protocols for specific features that you need. Pointers to SDKs are here on this page, and also some documentation for SDKs as well. ActiveSync. ActiveSync. It is lightweight synchronization protocol for Exchange Server, optimized to work on high latency and low bandwidth networks, and it's designed to minimize device power usage. Also high level of abstraction, similar to AWS. Provides access to email, calendar, context, task, documents. A transport layer here is WBXML over HTTPS, and it is industry standard. We have several non-Exchange Server implementations and wide range of clients on iOS, Android, Windows, and etc. There are 15 protocols in ActiveSync protocol family, approximately 900 pages, and first implementation was on Exchange Server 2003. Where to start? It is hierarchical, so you can start with basically MS ASCMD and go into specific features that you need. Typical usage of Exchange ActiveSync is mobile applications and also tablets and lightweight desktop applications. It allows for low bandwidth and high latency data connections while scaling reasonably on high-speed connections. Additionally, you should consider that there is not a full feature parity with Exchange ROPS and AWS protocols, and there are licensing requirements. Choice of protocols to use. We have 3 protocol families which are working with the same data, so if you need to choose between them, AWS is recommended for new applications, definitely. ROPS are very complex, and ActiveSync has special purpose. If you develop for Microsoft 365 for Exchange Online, definitely consider Microsoft Graph APIs. It provides modern authentication, seamless integration with other services like SharePoint or OneDrive, Azure, and so on. And new Exchange Online features are implemented in Microsoft Graph APIs. Here are starting points if you want to explore Graph. By the way, there is a blog which has very interesting way of learning Microsoft Graph in 30 days. And Graph has Explorer, it's a web application that allows you to experiment with those APIs. Now let's talk about resources that are available for you to use if you develop these protocols. First of all, we have Exchange Protocol Test Tools. Test suites for EAS, AWS, and ROPS protocol families. Both RPC and MAP HTTP are covered there. And test suites are interesting in a way that how they developed. We take normative language from protocols and develop synthetic client based strictly on this normative language, what protocol says. And then we run those test suites against a real Exchange server and making sure that they work. So you have a synthetic client implementation, you have code, and that code works against real on-prem Exchange server. So you can experiment with that in many ways. We also have field inspectors for ROPS protocols. They are implemented for MAPI HTTP. In general, we have a large set of resources which will help you. Here are links to all protocol documents. We have interoperability block, very helpful. Link to test suites, field inspectors, and we have free help for open specification, doc help, and Microsoft.com. And with that, thank you for your attention.